Hello, welcome back to BLENDERSUSHI live noding. In this video, I'm gonna explore one of the newer nodes. It's called a Vector Fractal. It's actually very similar to Vector Noise MK2, except that this one has a little bit more parameters to work with. I think they both can probably be merged together at some point. I'm not quite sure, but this one with a vector noise, we have option for scalar and vector and type of the noise, and then seed and then vertices. And this one is more advanced, and you can do more. This one is slightly simpler, but I want to talk about this. One thing that I rarely show is if you're new to Sverchok and you want to know what nodes does and not, you can look at the help here, select the node, and then you go to online or offline. Online actually is still not available. Offline is usually the one that will work. So you have this description. Would be nice. Maybe one day we're gonna have like examples, but that's kind of things that I'm doing. But yeah, like with Vector Fractal, you can check the help of the node as well. The offline help will give you a description what it does. So it generates noise function with this type, and then you can do this. You can adjust this lacunarity, octaves, offset. This is actually based on Blender BPY math utils noise. Yeah. Okay, so I can close this documentation, and let's get back to Blender. So in this setup, I have these boxes kind of moving around. They're actually scaling based on the noise, and I can control that using all these attributes. I think I'm gonna start from scratch. So let's do something here. File, save as fractal noise. Sverchok fractal. Fractal. Okay. And with this guy, I like to start using maybe just line. Let's try line. We have all these generators, and so this exploration is gonna be super basic. So if you're beginners to Sverchok, this should be useful. If you already know Sverchok, you can give it this node a try and what it does. Let's say we plug in a line into Vector Fractal. We know that line nodes will generate points, and then the edge is gonna connect the points together to create lines. While Vector Fractal with the points goes into the vertices. If we check on the stethoscope, we can see that we get some numbers. So this is so we provided these nodes with a bunch of vertices, and we get the output is like a scalar. It's only like a single value. We have because we have 5 points, we get 5 value here. Okay, so that's pretty much it. Basically, if we want to kind of disturb the line using the fractal, we can do that using vector math. Just add them together. Vector in, maybe disturb it in the z direction, plug that in, so we have that. And by default, it's not gonna do anything. We can play around with the parameter obviously. And one thing you can do, however, you can use vector move with the line itself. Let's say if we kind of pushing the line points in the X. So this is the original line, and this push line goes into the noise. What's gonna happen now, as the points got pushed, we're gonna get that kind of motion. even though original points is pretty much static there, this one is being pushed. We can use a frame info, and then with that thing plug, okay, it's the motion is a bit too fast, and then we can use this multiplier. So that's one way you can kind of explore this noise. Of course, it's not the point. You can just plug in the edges and you get the line, and you can have as many as you want. This will generate the value for you. Control the stepping because this is line, and have that kind of design. So that's this is first, and then obviously you can play around with this multi-fractal, heteroterrain, all these options. Gonna give you interesting line pattern. So that's first. What's next? You can of course use this to generate skin modifier, vertices and edges, and we have that. We can plug in this scalar value into the radius because they're pretty much like a single value, and you get this. It's pretty unusual. Maybe we want to have more control over this guy. We can map range. I think the value actually kind of goes between -1 and 1. You adjust the value. Okay, that's the offset of the noise. Yeah, something like that. Voronoi, Berlin, Fractal. We have a little bit of variations there. Maybe we can use it for the spider thing. But anyway, that's it. This is one way to look at it. You can also use instead of line, you can use circle or grid. Let's try using grid. Grid plane, of course, we're gonna will give you a bunch of points. So if I do that, so that's the default grid. But if we plug all these points, vector positions into the fractal, we're gonna get something completely different. Plug that in and plug that. Okay, we are getting something that's looking more like ocean wave. Probably this is how the ocean modifier also being created. Let's make it like 5x5 for now. Make it simpler. Fractal, and we can control this, all these attributes. This multiplier for the time. Of course, point is not so much, not so interesting. What Sverchok can do, of course, turning points into transformation. So we can use a matrix in. Just plug this into the locations, into this. Be careful here, don't just connect that. We want to create a transformations, and this is just an empty transforms that we can just use. If we plug in like a box, we can end up with boxes, and these boxes are being duplicated and placed on the position of the points, plane points that being disturbed by the noise. So these are always the things that probably you want to try if you're first starting to use Sverchok. So now we have 64 of these boxes being generated on the fly, and we disturb it using the noise. Yeah, still pretty basic, but I found it really interesting. It's really fun to play with. Other than the locations, you can also, of course, because this is the matrix transformation, you can supply scale and rotations. Scale rotations, let's do the scale and plug that in. Okay, it's now 0, 0, 0, so you can't see anything. Let's make it 1 in X and Y, and the Z we can control. For the Z, we can use the vector fractal, and we get that design. You can also, of course, use other things like random vector or whatever. For now, we keep it simple. Let's say we don't move it ups and down, just cut it in locations. We're just gonna use the grid position. Now we have this design. With the scaling, if we want more control, I always use the map range. After the noise, I use the map range and then change the value to suit my numbers. Actually, this is more like that. This should go in there and then plug into that guy. Okay, so that's more control over the noise. 0.1. At this stage, really, it's totally up to you what you want to do with it. Make more. Yeah, that's pretty much the basic function of this vector fractal. I like just to have this nodes, just additional for what we have already with vector noise. We can use all these similar functions like Vector Noise MK2. It's outputting only scalar value, not vector, like this guy. Control, just more parameters. Fractal, multifractal. I found this guy are very much very subtle, the difference between all this. Some value can be very sensitive, but just with this kind of thing, you just give it a try and then you're gonna get a result right away. Remember that if the value is over 1000 or over 10,000, it starts to slow down, and it's actually a lot faster if you use instancing. What I mean is mesh instancer, maybe the dupli. Let's say I'm using a box here and then use as a child, and then if I plug in the matrix, this guy is actually a lot faster than this guy right here. Let me try if this is working. Scale children, one object only. Maybe dupli instance doesn't quite work. Maybe this one will actually works. Okay, yeah, this one actually works. Update group. Yeah, these guys will work a lot faster than the other one. We can have like a super big number like 10,000 and still gonna update interactively. So yeah, just play around with this vector fractal. Like I said, it's very similar to vector noise. If you have any questions, suggestions, just let me ask. Just let it done. Left it on the comments below, and I will answer. Thanks again for tuning in, and I'll see you in the next video.